total return. So consider an investment that grows from an original principal amount P, and later on it's got a balance we're going to call A in it. So it started with P dollars and it ended up with A dollars. The total return is the relative change. So for instance, let's say we had $1,000 and then 10 years later we had $11,000, and we did it, of course, in the 10 years. So how much is the total return? You've gone up 10,000 in 10 years, you go up $1,000 a year. So that's what they're talking about here. Total return is the new value minus the starting value over the starting value multiplied by 100. So new value minus starting value, we call that A minus P over P. Starting value or starting principal, that's why they use a P, is always the same. This should look pretty familiar to you because it's a lot like the relative difference or the percent increase decrease formulas that we worked with earlier in the year. The new value minus the original or starting principal divided by the starting principal. That's very similar to that formula that we worked already in the review questions today. So let's do an example. Suppose you decided to invest in some real estate property in the year 2004. You paid $27,500, but you decided to sell and you received $43,400 for the property. What's your total return percentage? Go ahead. You may have wanted to have taken a picture of that previous formula, or you may understand it, one or the other. Okay, so the total return is the $43,400 minus the $27,500 divided by the $27,500. And if you crunch those numbers, it'll show you 57.8%. That's pretty good. Growth over 9 years, right? That's over 6% a year. Let's try another one in case you struggled with that one. This time, the original investment is $27,500, and in 2013, you sell and receive $45,400 for the property. Now, what's your return? Okay, so let's see what we come up with here. $45,500. The last, it should have been $45,400. Oh, sorry. Oh well, I'm going to be slightly off because this should have been a 4. Minus $27,500, 18 grand. It should have been 17.9. If you had 17.9, you did it right. Divided by 27.5, it's 65.5%. I'm just going to crunch the numbers on what it should have been here. 45.4 minus 27.5, and then I have to divide by 27.5. Yeah, it should be 65.1%. Okay, so 65.1, almost the same. Now, annual return. Consider an investment that grows from its original principal P to a later balance A in Y years. Same setup we had before. The annual return is the average annual percentage yield that would give the same overall growth. And again, they give you a formula. So you just follow the formula. A over P to the 1 over Y power minus 1. So suppose you decided to invest in some real estate property again in the year 2004, and the amount of your original investment is $27,500. In the year 2013, you decide to sell and get $43,400. What is your APY, your annual percentage rate return? Well, there you go. The annual return is $43,400 minus the divided by the 27.5 to the 1/9 power, and then you subtract 1, and that gives you 5.2%. Okay, so those are some formulas and stuff like that that's going on. Now, let's take a look at just a quick review of exponents and laws and stuff like that. I'm sure you'll see a little bit of this on quizzes, but it's important that we be literate and fluent in quantitative things, which include exponents. So this is a convenient point in time because we're doing so many exponent problems to mention exponents. So here are some things about exponents that you should know. That n to the n power is a number multiplied by itself n times. We call the big N the base and the little n the exponent. I literally tutored my niece who was in 6th grade at South Ocean Avenue Middle School in Patchogue, New York, where I used to teach at times. I taught there and at the high school. My niece going to that school today, I tutored her and two of her friends, and she's in 6th grade, and it was exponents. Only the first line. The rest of it, they definitely didn't cover the rest. Actually, I did cover the last line with them too. So a to the 0 power is 1. Anything to the 0 power is 1. There's a really good reason for that. I'll explain it to you very quickly, but without being able to write, I don't think it's going to make a lot of sense. So look, if I have x to the 5 over x to the 5, you subtract exponents, that gives you x to the 0. But anything divided by itself is also 1, so therefore x to the 0 has to be 1. Next up, if you get to a negative exponent, negative exponent, that just means reciprocal. It doesn't mean you make the term negative. Notice there are no negative signs here whatsoever. Okay, it does not make it negative, it makes it the reciprocal. That's why the 1 goes on top, a to the positive n power. If you're multiplying with the same bases, you add the exponents. If you're dividing with the same bases, you subtract the exponents. And if you raise a power to a power, you multiply. Basically, it's one step down in the process. Multiplication turns into addition, division turns into subtraction. Remember, multiplication is repeated addition, division is repeated subtraction, and then when you raise a power to a power, it's multiplication, because multiplication is what leads to exponentiation. So here's some questions for you to do. Go ahead, do, stop and start. Okay, so express 3 to the 4th as a product of factors. 3 times 3 times 3 times 3. Evaluate 5 to the 0. Anything to the 0 is 1. A negative exponent means reciprocal, so it is 1 to the 9th. Simplify. The rule is to add exponents, so it's x to the 10th. Simplify. Subtract. This is not n squared. It's n to the 4th. Simplify. These are the ones that, of all of the things I put on the board so far, this is the one that is the trickiest for kids. This cube outside the parentheses applies to everything inside the parentheses. So the 3 applies to the 2 and the n to the 5th. So the 2 gets cubed also. So 2 to the 3rd power is 8, right? 2 times 2 times 2. That's 8, not 6. So it's 8 n to the 15th. Raise a power to a power, you multiply, like the rule says on the left. Now, not only do we want to do a quick exponent review, we want to do, a quick roots review. The square root is the thing that times itself equals whatever you're taking the root of. So the square root of 4 is 2, because 2 times 2 is 4. Or the square root of 81 is 9. 9 times 9 is 81. The cube root is a number times itself and then again. So the cube root of 27 is 3, because 3 times 3 times 3. Notice cube root is a 3, and the 3 is used as a factor 3 times, is 27. And the 4th root of 16 is 2, and that's because 2 used 4 times as a factor is 16. When I do the nth root of x, if I want to express it as an exponent, it's 1 over n. That's very similar to the previous slide, right? And then if I do an example, 64 to the 1/3 power means the cube root or the 3rd root of 64, which is 4. So those are some basic things to know. Here are some questions for you to do. Go ahead. I would do the first 4. I wouldn't do 5 and 6. Just do the first 4. We'll go over 5 and 6 after we do the first 4. Okay, I'm sure you must have done stop and start by now. You know the procedure. Anything to the 0 is 1. 5 to the negative 2. A negative exponent. That's 1 over 25, because 5 squared is 25. The square root of 225. Number times itself equals 225. 15. And number 4 is n to the 1/5 power. And I just want to emphasize here that under the radical, n is to the 1st power. When you don't write a power, it's always 1. And that's why it's 1 up in the numerator. So that should help you do number 5. Go ahead, do 5, stop and start. So that would be n to the 3/7, right? I like to say power over root. The silly thing I used to teach when I would teach about fractional exponents is, you remember like when kids were in plays in kindergarten, and they would be like the dumbest plays, and a kid would be like a tree, you know, and they would cut a hole out for his face to look out at the tree, and his arms would be in the branches of the tree, and I could just see a little kid coming out and going, The roots of the tree are down. The power is in the leaves. The roots of the tree are down. The power is in the leaves. So the roots of the tree are down. It's the seventh root, so it goes down. The power is in the leaves, and the leaves are in the upper part. So n to the 3/7 power, right? The power is in the leaves, so that's the upper part, power, 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 and then the roots are down. And then do the last one here, number 6. So that would be n to the 2/3. Okay? All right. Very good. A couple of other things to talk about here. A stock is it's when you have share of an ownership in a company. It's kind of like Shark Tank when they buy a piece of the company. When you buy stock, you're buying a piece of the company. Your money goes to the company, and the company is supposed to build and improve. It's capitalism. And then as they do, you get money back for your stock. It's a really cool way. A lot of people, they get very upset with capitalism, particularly some younger people, and they'll say, oh, it's just the rich people. No, absolutely not. Anybody who tells you that is dead wrong, because I am not a rich person, and stocks put me there. My grandfather never graduated high school. He was not, well, he did end up a rich person. He died a millionaire, but he never made more than $30,000 in a year, and he ended up a millionaire because 10% of every paycheck went into stocks. So stocks are for anybody who buys the stock, and then you hold on to it, and you get really successful. I'm sure you've heard the stories about, well, if I would have known and bought Apple stock or Disney stock or something like that. So stocks and working stock markets, and later we'll talk about mutual funds. These are great ways for the average person like me and you to take advantage of it and gain great long-term wealth. Now, the only thing about a stock is this: you can't pick the losers, all right? You have to pick a good stock. My father-in-law, he's passed away now, but years and years and years ago, he got a tip to buy a stock called Teléfono de Mexico. And it was when they were putting telephones all over Mexico. And he made an enormous amount of money with that. And because of it, he was able to buy land in Callicoon, where we live now. And eventually, part of that land worked its way down to us. So this is the kind of thing, and my father-in-law was a detective. This is the kind of thing very middle-class people do to be more successful in the world. Now, what's the difference between a stock and a bond? Because people say stocks and bond. A bond is a promise of future cash. You buy a bond by paying some principal amount to the government, like a savings bond or something like that, and the issuer pays simple interest. You know how that doesn't get much. Bonds don't make the money like stocks can, but some bonds also don't lose money. And they promise to pay the principal back at a later point in time. Okay, so stocks, bonds, calculations, things like that. I got to make one more video before we're done with this thing.